Hey guys, we're on day 7 and we're going to talk about the measurements of tangent, secants, and chords. We just talked about the measurements of tangents, if there's two tangents, but today it might be a tangent and a secant, and that follows a different formula. Okay, so in our warm-up it says in right triangle ABC, altitude CD is drawn to hypotenuse AB. And so you have to remember that altitude CD drawn to hypotenuse AB are those pigs love low hurdles, pigs are awesome pets questions. And so our right triangle got tipped over. His right angle's up in the air, and his hypotenuse is here. Okay, and they're telling us altitude CD has been drawn in, and we'll call that C, and we'll call that D, and then we'll call this A and B, so that the altitude CD is drawn to our hypotenuse AB. And they're going to tell us that AD is 2, that DB is 8, and they want us to find the length of CB in simplest radical form. Okay, and so if we think back, we have pigs are awesome pets and pigs love low hurdles. Pigs are awesome pets, where this is a 1 and this is a 2. However, guys, we don't have an altitude at all, and this question's not asking us to find it, so it's not that question. Instead, we're going to go pigs love low hurdles. Okay, where all the P's and L's are either 1s or 2s. And so coming up here, we're going to call 2 our projection 1. We're going to call 8 our projection 2. And we're going to call the X leg 2. And therefore, I now know that these are all 2s. Okay, and so now we're going to go ahead and substitute P2 out for our P2, which we called 8. We're going to substitute our leg 2 out for what we're finding, which is X, equal to the same leg 2, which is X, over our whole hypotenuse, which you guys can see is 2 and 8 together, and therefore 2 plus 8, part plus part, equals the whole hypotenuse, which is 10. We'll go ahead and cross multiply, and we end up with X times X, which is X squared, equal to 8 times 10, which is 80. We'll go ahead and take the square root, and 80 is not perfect, which is why they're saying to put it in simplest radical form. So we need the largest perfect square that goes into it, which is 16, and it goes in 5 times. And the square root of 16 becomes a 4. And the square root of 5 stays, and this will be the length of CB in simplest radical form. Okay. All right, coming down, guys, we're going to talk about finding the lengths of chords first. Okay. So we know when two chords intersect, they form interior angles, and we have formulas for the angles, but what if they give us the lengths of the chords? Okay, all we have to do is part times part equals part times part. Okay, where the two parts come from the first chord and the two parts of the second chord come secondly. All right, so a pretty easy formula. And so number 1, it says if chords AC and BD intersect at E, and that BE is 6. So from B to E, this length here is 6. ED, from E to D, that length is 10. Okay. And then they tell us EA, E to A, that length is 12. And they want us to find from C to E, which we don't know, okay? Or we can call that X if we want. So because this is about lengths of chords, we're going to try to follow this formula, but we need a part and the other part from the first chord. So you guys can see that blue chord, okay, has been divvied up into 2 parts of 6 and 10. So one part is 6, one part is 10. And then the formula says to set that equal to the 2 parts being multiplied from the other chord. So 2 parts from the second chord. And you guys can see that one part is 12, and the other part is the part we're solving for, so we called it X. All right, 6 times 10, guys, is 60, and that's equal to 12 times X, which is 12X. To solve for X, all we're going to do is divide by 12, and X comes out to equal 5. And therefore, CE is what we called X, and so CE comes out to equal 5. Okay. All right, number 2, it says in circle O, chords MN and KL intersect at Q. So we'll draw a circle. We'll draw one chord. We'll draw our second chord. And the name of the first chord was MN. And the name of the second chord was KL. And they're saying that they intersect at Q. And that if MN is 16, now that's a little bit tricky because MN is the whole chord. So that's a little hard to label. So I'm going to hold off on that information. I'm going to see what else they give me, guys. KQ is 6, and that is one of the parts. So we'll put 6 there. LQ is 8, and that's the other part. So we can put that there. They want you to find the length of MQ. MQ, we'll put an X there because that's what we're trying to find the length of. And then if you guys remember that this whole chord is 16, so we need to call this part of the chord something, and so we're going to call it 16 minus X. Whatever X is, okay, and the whole chord is 16, 16 minus that one part should give us the other part. So a little bit tricky to come up with that expression, but hopefully it makes sense, okay? They also tell us this information here. We're not going to use that until the end of the question. All right. So what we're going to do is we're going to do the two parts from the one chord multiplied together. So part plus part. One part is X. The other part would be 16 minus X. And that's going to be equal to the two parts of the other chord. One part is 6 multiplied by the other part, which is 8. All right. So this one's a little bit trickier than the last one. But we're going to use our algebra to distribute, and we'll get 16x. X times negative x is negative x squared, equal to 6 times 8, which is 48. And you guys can see they're going to turn this one into a quadratic or a trinomial. All right. Problem is we don't like negative x squareds. They make our factoring harder than it has to be. So we're going to add that x squared to keep them positive. And we're going to subtract the 16x. Okay. Hopefully you guys remember that a squared term means you're going to have two answers. You're not going to get those two answers unless you factor, and you can't factor unless you're equal to 0. All right, so we have x squared minus 16x plus 48 equal to 0 now. Now we can set up our x box. Our multiply is the last number, which is 48, and our add is the middle number, which is negative 16. And if we find the two numbers that do that, we're going to figure out that they're 12 and 4, except both have to be negative to get a negative 16. And now when I multiply them, I get a positive 48. Because these are a nice, easy trinomial, we can go right to our factors of x minus 12 and x minus 4 equal to 0. Okay. We'll come up here and solve them. X minus 12 is going to turn into x equals 12. And x minus 4 is going to turn into x equals 4. Okay. And so now remember this part right here where they said MQ has to be less than NQ. So if MQ is 12, that would make NQ 16 minus 12, which is 4. And so now MQ is less than NQ. MQ is more than NQ. So we're going to go ahead and reject this because it doesn't fit what we need. All right. So we're going to go back up and let's say x is 4. So this side would be 4. 16 minus 4, this side would come out to be 12. And now MQ is less than NQ. And so we can go ahead and say that MQ must equal 4. So that 16 minus 4, the other side is 12, so that the whole line segment MM ends up being equal to 16. Okay? It's supposed to be a Q. All right. Okay, guys. So that's what we do with chords and lengths of them. We do part times part equals part times part. Okay? Now these follow a little bit of a different formula. This is for finding lengths of tangents and secants. Okay? So it's for tangent and secant or two secants. It doesn't work for two tangents because remember, two tangents are equal. Okay, like the ice cream cone. So this is two secants. And the formula says whole times outside equals the whole times the outside. All right. So if we're looking at this secant here, the whole thing from beginning to end would be called AC. And the outside part of it is just this little piece, which is called AB. All right. If we look at the other secant, this one here, the whole thing would be called AE. The outside part would be called AD. And so if we had the lengths of those line segments, we would plug them in and solve our equation. Okay. In the second picture, this is a tangent on top and a secant on the bottom. Oops, secant. All right. It follows the same formula too, so whole times outside. So if you look here, guys, at the tangent, the whole tangent would be PA. But remember, guys, a whole tangent is already outside. It's not allowed inside the circle. Otherwise, he's known as a secant. So the outside part is also PA. Okay. On your secant here, the whole thing would be called PC. And the outside part here would be called PB. So be careful, guys, that these ones follow different formulas. So they're not part times part. They're whole times outside. Okay. So a little bit different than chords. Try not to apply the same formula to them because you'll get the wrong answer. All right, we'll practice on the back side with plugging in. Okay, I'll see you guys then.